got his bachelor in 1993 from Tokyo, Japan University.
You want to say years?
There's no fussy,
yeah, I'll say that.
Yeah, and his master in 1996, 5 years of Nevada in the US, and finally he got his PhD in 2000, 5 years of Arizona. He's the science team member in many NASA's mission, and he's the winner of a number of awards and honors. He published a lot in this field, in the field of estimation of vegetation in the
Yeah. Yes. Okay, thank you very much for the introduction. All right, so let's go casually. So today, thanks for the opportunity for giving this seminar. I'd like to talk about this work that my lab has been working for last a few years. It's evaluation of SUMI NDP VIIRS Vegetation Index EDR, their product intercomparison with Aqua MODIS. Does everybody understand any of all of these?
Index.
So anyway, so being a graduate chair has nothing to do with this presentation, but it's such a demanding job. You know, I thought I deserve to list one of my affiliation. And I would like to acknowledge contributions from these individuals, Jamsan, Jao, Kenta, Anna, and Marco Vargas, Nikolai Shabanov. These are my colleagues at the NOAA, and Alfredo Fuete from Australia. Okay, so let's start with defining jargons. First, SUMI NPP. What's SUMI NPP? SUMI NPP stands for National Polar Orbiting Partnership. This is the satellite mission which was launched on October 28, 2011. And at the time of launch, it has a different name. It was called the National Polar Orbiting Operational Environmental Satellite System Preparatory Project. Yeah, same acronym, but different name. And upon the launch, it was renamed in honor of the Dr. Sumi, who is considered the father of satellite meteorology. And it's been renamed as SUMI NPP. NPP here stands for National Polar Orbiting Partnership. All right, so how this SUMI NPP is placed in US satellite system. So United States here has an operational satellite monitoring program that consists of geostationary satellites and polar orbiting satellites. And basically, so far, I can use this. Operational monitoring of polar orbiting operational satellite has been conducted by this NOAA sensor series. And new technology developed, so NOAA sensor satellite series will be replaced by the new sensor series called the JPSS, Joint Polar Satellite System. NPP is designed as a risk reduction mission going from NOAA satellite series to JPSS satellite series. Yeah. But at the same time, NPP is positioned as an experiment to continue EOS data record that started with Aqua and Terra. So NPP is considered a bridge mission, but this has two bridge purposes. One is to bridge NOAA sensor series to new JPSS. The other is to continue Aqua Terra NASA satellite sensor through NPP to JPSS. Okay, This is a revisit of the same information. So, as far as the sensor is concerned, global operational satellite sensor began with AVHR. I can go here. Oops. Yeah, AVHR. The record starts in 1981, and based upon the experience gained AVHR, NASA developed these MODIS satellite sensors, which are on board both Terra and Aqua satellites. And while MODIS are being experimented, the new generation of AVHR sensor series was launched by NOAA and operated. Yeah. And from here, both NOAA and NASA are transitioning to VIIRS sensor. So there used to be two, AVHR and MODIS, but now we are going to VIIRS. VIIRS is supposed to fulfill the need for both NOAA's operational weather forecasting and NASA's climate change science. So then what VIIRS stands for? Let's define the second jargon, VIIRS. It stands for Visible Infrared Imaging Radiometer Suite. This is the next generation sensor series, as I just mentioned. And VIIRS will be on board, NPP, but it will be on board on the JPSS platform. And the first VIIRS is on board NPP. So it's a polar orbiting satellite, and much of the sensor characteristics are in between AVHR and MODIS. From AVHR perspective, it's a significant improvement in sensor technology, including spatial resolution, number of spectral bands, and the signal-to-noise ratio. But from MODIS perspective, there is an improvement in spatial resolution and also signal-to-noise ratio, but number of spectral bands have reduced from 36 bands in MODIS to 22 bands in VIIRS. Okay. So NOAA's interest has been significant upgrade in monitoring capability and data quality going from AVHR to VIIRS. And NASA's interest has been whether VIIRS is suitable to continue highly calibrated data record begun with MODIS sensor. Dual purpose. So how does this VIIRS image look like? Here you go. With no animation. Yeah. So this is a near polar orbiting satellite. You can see this line, yeah? That's the orbit. So if you mosaic all images in global scale, this is what you get. And this is the first complete global image acquired in November 2011. I have mouse works. Let's see if this works. Yeah, there's virus. Okay. Yeah, that's the VIIRS image of Eastern Hemisphere reprojected onto hemisphere. So if you zoom in, you can see actually quite significant details. No, not really from there. From here, it looks really nice. Okay. Not so good. Yeah. So that's the VIIRS image data. Let's go back to slide. So this VIIRS data, well, there are some technical difference. This is some more detailed technical differences, contrasting number of bands, MODIS and VIIRS. I can just say that VIIRS has a 22 spectral bands, whereas MODIS has a 36 spectral bands. And you can see that MODIS VIIRS, VIIRS is missing many bands that MODIS has. And this is just a band path plot on wavelength graphical view. So with 22 spectral bands, it is still a significant upgrade from AVHRR, which had either 5 or 6 bands. And learned from MODIS project is VIIRS. From VIIRS data, this many number of standard products are generated. And these standard products generated from VIIRS are termed environmental data records, EDR. It's just a technical term, it's a satellite product. So many products are in a cloud, yeah, and there are 5 standard products for land. And then our lab, my lab, happened to be involved in the development of this vegetation index product, of satellite product. Okay, so that's the overview of VIIRS and SUMI NTP. Okay. So then, what's the spectral vegetation indices? Okay, so spectral vegetation indices, there are many definitions, but I think the most intuitive definition which I use is that it is a measure of vegetation photosynthetic capacity or photosynthetic activities. So it captures how active vegetations are in terms of photosynthesis. This is a very good way to define. So, but this is VI is a vegetation indices, so it doesn't. It's not giving you any absolute measurements. It's all relative. So then, how useful VIs are? It becomes really useful if you start looking at spatial variation and the temporal changes in photosynthetic activity. Absolute value of VI may not have a significant meaning, but if you use VI to change tracking over time and track changing VI values over space, then VI becomes powerful. And I'm just listing 2 of the most popular VIs, yeah? Normalized Difference Vegetation Index and Enhanced Vegetation Index. Ndvi is a heritage from NOAA AVHRR sensor series, whereas EDR was a new index designed for VIIRS MODIS application. So some example, vegetation index time series is used as an input to derive land cover classification in large scale. Yeah? Seasonal change in vegetation index value correlate very well with vegetation type, because it captures changing photosynthesis. So this is used as one significant input for generating land cover type. Those different vegetation types exhibit different temporal curves. And second, so this was an application of Ndvi for climate science. This is a classic paper, but it had a significant impact. The author, Dr. Mineni at the Boston University, along with other scientists, analyzed Ndvi time series from AVHRR sensor and basically found that the CO2 concentration increase in CO2 correlates with increase in temperature that seemed to have triggered longer growing season, and that resulted in increased plant growth. Yeah? CO2 increase of temperature, longer growing season, then increased plant growth. Yeah? And yes, this had a significant impact at that time. Still is now. And this one, quite a well-known one. With the highly calibrated MODIS data, a group of scientists found that vegetation greening increases during dry season. Intuitively, dry season means less water. Yeah? So then we would expect a decreased plant growth. But this group of scientists found that the vegetation growth increases during wet season, dry season, excuse me, for the Amazon forest because there's still enough water. Yeah, but this paper, triggered so many responses and significant debate about Amazon greening up during the dry season or not. It's still under intensive research. And finally, this one you have, I think most of you have seen this already. Another application, vegetation index. NDVI has been used to track droughtness. Drought monitor. This is used as one input for operational drought monitor in the United States. So these applications of vegetation indices, they are used for operational monitoring as well as understanding climate science, climate vegetation interaction. So then what's the VIIRS Vegetation Index? There you go. VIIRS Vegetation Index, EDR, official product is produced daily. It's a daily product with a spatial resolution of 375 meters. And this index, so here is one example. I hope you can see. It's a data of the Amazon. All these white dots, these are color composite. So it's a dark green over Amazon tropical forest. And all these white patches are the residual cloud contamination. So if you compute the vegetation indices, you can see that these yellow dots, white dots, that's caused by cloud contamination. But with new flag called adjacency cloud flags, this cloud flag will mask all these suspicious quality observations. So basically, all these remaining residual cloud contaminated pixels can be screened out using adjacency clouds. So that's the improvement we have done. I can skip this one. And another algorithm. We show the spectral bandpass difference. We wish to use MODIS and VIIRS as a continuous time series. So we want to get rid of this systematic difference caused by bandpass differences. So one of our former colleagues, Kenta Obata, derived theoretically a math equation to transform VIIRS Vegetation Index to the MODIS equivalent values. The equation is fairly simple, and it actually contains 4 coefficients, K1, K2, K3, K4. I think he originally used a C, but I told him to change to K, following his initial Kenta. Anyway, with this, here is a systematic difference observed between MODIS and VIIRS EDR, but upon spectral transformation by his method, you can reduce the bias to 0. Spectral transformation. And the last algorithm improvement is being done by Jargons, that we would like to develop backup algorithm so that the vegetation index value becomes reliable over snow ice surface. So I'm just showing the image. You see this image? Here, any snow-covered area becomes pink, yellow, red. It should be green. But with the backup algorithm, we can suppress these suspicious vegetation index values over snow-covered area or over clouds. Yes. So this is derived based on a collection or set of conditional expression. If reflectance is higher than that, then switch to this. If reflectance is lower than that, switch to that. So we are basically empirically developing a set of conditions that will switch vegetation index equation from one to another. So these are the currently going activities, validation and algorithm development. Okay. So actually that's it. Here's a acknowledgement. Thank you for NASA land peak and JPSS IDPS for providing VIIRS MODIS data. And although I had only brief preview, the ground data provided by all these folks. And then funding source. This work was supported by grant from NASA and NOAA contract. Yeah. Yes, that's all. Thank you very much. Any questions? Yeah, you should have some questions.
Sorry, I have a question. So
Yeah.
finally we couldn't figure out, which product is better, MODIS or VIIRS?
I'm just concluding at this point that they are comparably good. And in terms of signal to noise ratio, VIIRS seems to be way better than MODIS because VIIRS is a new sensor, much higher signal to noise ratio. But processed data, via algorithm, MODIS is way more consistent. The VIIRS algorithm, I think, needs more attention and more improvement. It needs more time to mature. So in terms of maturity, MODIS is more mature, producing more consistent data. So VIIRS performs well over a certain geographic area, certain condition, but not performing well all the time. Yes.
Do you anticipate any loss in VIIRS not having two satellites and not having a morning and afternoon over?
Oh, yeah, good question. Yes. That relates to satellite mission planning. So, here the green one, METOP A, METOP B, METOP C. This is the polar orbiting satellites administered and operated by European Space Agency. So, US gave AVHRR to European Space Agency. All these METOP carries AVHRR. So you have an AVHRR in the morning and the VIIRS in the afternoon. So we don't have a VIIRS in the morning and afternoon, but idea is that there is a AVHRR in the morning and the VIIRS in the afternoon. This constellation, supposed to provide morning, afternoon coverage, and if one goes bad, you have the other. There is a Japanese satellite, GCOM. Yeah, anyway, never mind. Yes?
Are there any issues with the decreased band number of bands, or is it where they just decided that they just didn't add that much more?
Yeah, I'm not sure the reason for the decision of reducing number of bands. But as far as vegetation index products are concerned, we don't see any problem. But I've heard that reduced number of bands could translate into a lower detection capability for clouds, for example. But that's part of evaluation that the NASA team was tasked. And then so far, I've been hearing that only positive news, yeah? Meaning that with a reduced number of bands, VIIRS can still serve to continue MODIS data recording. Yes?
So we're doing a comparison of EVI to VIIRS, the MODIS to VIIRS EVI product. as EVI increased, the difference between the two measurements also increased. How does that affect the possibility of being of having them be continuous, kind of a long-term data record, since it's not consistent over?
Yeah, good questions. So this new equation that Kenta Obata developed so far, that should resolve that problem.
Well, I thought that only addressed the bias, not the uncertainty.
Okay. So bias can be corrected, and then there is a residual uncertainty. Yes, there remains a residual uncertainty. But we need to think of a source of uncertainty, sources of errors, and then sources of errors are random errors, and I'm 90% sure this is due to mismatching of pixels, spatial mismatch of pixel positions that appears as a too excited, yeah. Yeah, mismatching of pixels. So if you have a complete matched pixels and then derive the relationship, I don't think we see much uncertainty. Yeah. So if you can take care of bias very well, then the continuity, we can establish quite a good continuity between VIIRS and VIIRS. It's not like AVHRR. Okay.
Any question? Okay, thanks.
Yeah.